Dear learners, in this video, we will be learning a problem in kinetics involving work done by a force. Work done by a force. So we know the mathematical expression for work done as W equal to F into S. W equal to F into S, where W is the work done, F is the force, S is the displacement, and S is in the direction of the force, or F should be in the direction of the movement, or at least its component is to be considered, that we have seen in the previous video. So in this problem, a block of weight 800 Newton is placed on a rough inclined plane. This plane is rough. The inclination is 30 degree with the horizontal. We need to find the work done in pulling this block up the incline through a distance of 5 meters. This is the problem. What is the work done in pulling this block up the plane through a distance of 5 meters? So to solve this problem, we will resolve this weight into two components, so that this will be the component which is parallel to the plane will be 800 sine 30, and the other one will be 800 cos 30. Which one? Which is perpendicular to the plane. Okay. So as the surface is rough, we need to consider the frictional resistance also. To find out frictional resistance, we need to consider the normal reaction. Then if we apply a force P in this direction, in the upward direction, up the plane, the frictional resistance will be in the downward direction. This will be the frictional resistance in the downward direction. So Fk equal to, or Fk equal to mu k into Rn, that we know. Fk will be in the downward direction. Okay. Then, so we will try to solve this. We will consider the forces perpendicular to the plane. Consider the forces acting on this body perpendicular to the plane. Which are the forces acting perpendicular to the plane? One is 800 cos 30 acting downwards, and Rn, the normal reaction, acting vertically upwards. So we know there is no motion perpendicular to the plane. In this direction there is no motion, only moving in this direction upwards. So as there is no motion in the perpendicular direction, sigma F in the perpendicular direction must be 0. Net force must be 0. That gives, let Rn be positive, therefore Rn minus 800 cos 30 equal to 0. That means Rn equal to 800 cos 30, or it is equal to 800 into cos 30 equal to 692.8. 692.8 Newton is Rn. Once we know Rn, we know how to calculate the friction, kinetic friction. Fk equal to mu k into Rn. Okay. So in this question, the value of kinetic friction is given as 0.3. Therefore, Fk equal to 0.3 into Rn is 692.8. So it should be equal to 207.84. That is the frictional resistance offered by the surface. So we have all the forces now. Now we will find out the work done by the force P. How to find out P? Let us assume that the body was moved without any acceleration. That means it was moved with a constant velocity, uniform velocity. No change was there, no acceleration was there. Therefore, there was no acceleration. That means there is no net force. So the force P and the opposing force must be same. Force P and the opposing forces must be same. Here, what are the opposing forces to force P? First one is 800 sin 30, second one is Fk. Both these are in the opposite direction of P. So to pull the block upwards, minimum, the force should be minimum equal to the sum of 800 sin 30 and Fk, isn't it? So let us see. If there is no net force acting on the body, that means sigma F equal to 0 parallel to the plane also. Sigma F equal to 0 parallel to the plane also. That gives P is taken as positive because it is in the direction of motion, minus 800 sin 30 minus 207.84 equal to 0. Equal to 0. That gives P equal to sum of 800 sin 30 and 207.846. Okay. So this value will be coming around 607.85 Newton. Now we have P, the force P required, then the work done will be P into S, that is 607.85 into 5, and that should be equal to 3039.23 Newton meter. The answer is work done by the force is 3039.23 Newton meter.